Alright, so here we go with our topic 3 equation study guide in preparation for Tuesday's test. And we'll take a look at how we approach all these things. So here we go. Number 1, we're taking a sentence and translating it into an equation. So for number 1, it says the sum. So that means you're going to be doing an addition problem. So we'll put a plus sign. And it says the sum of 5 times a number x. So we're picking your variable. So since we say a number x, that means you have to use x. So 5 times x we write as 5x. And then it says and 3. So and 3 means we're going to add the 3 to your 5x. When we see the words is the same as, that means equals. And then it's 15. And you don't have to do anything else because it just said translate. Number 2 says 4 times the difference. So it doesn't say 4 times a number, it says 4 times the difference. What that means is you're going to multiply 4 by a subtraction problem. So we need to put that subtraction problem in parentheses. And in the parentheses it says the difference of b and 6. So b take away 6. And then again we say is equal to 16. No solving necessary. Number 3. Now we get into actually solving. So we have negative 6 plus g equals negative 11. Now to solve this, we're going to be playing our game of opposites, which means we're always doing the opposite of the number we're trying to get rid of. The goal is to get the g by itself. So we look at this minus 6 and we do the opposite of subtracting a 6, which is to add a 6, because that cancels out to make nothing. And because equations are balance beams, so to speak, what's on the left has to balance the right, so what you do to the left you have to do to the right. So now we have negative 11 plus 6, which is negative 5. If you want to check your work on Tuesday, you would take this negative 5 and plug it in for g to see if it works. So is negative 6 plus a negative 5 equal a negative 11? Yes. So since negative 5 works in the problem, we know that we have the correct answer. Alright, on to number 4. For number 4, it says select all the equations that have the right solution. So you could solve each equation out to see if it works. However, there's a quicker way. If they're asking you if the x value is a solution, that means it has to work in the problem. So when it says 2x plus 5 equals 19 and x should be a 7, you plug in your 7 and see if it works. So that gives you 14 plus 5 equals 19. Check, that works. So the first one is an option of working. The second option says x is 3. So the equation is 3 plus x. So now the x turns into a 3 plus 2 minus x, which is also a 3 again, equals 16. Nope, this does not work at all. This makes no sense. So that x equals 3 is not a solution. Our third one says x plus 2, and the x is an 8. So 8 plus 2 divided by 5. And it's supposed to equal 2. Well, 8 plus 2 is 10. 10 divided by 5 does equal 2. So option 3 is good. Option 4 says 6 equals 2x, and this time they say the x is a 7. So 2 times 7 minus 8. So that's 6 equals 14 minus 8, 6 equals 6. Yes, that one works. And finally, our last one is 14 equals 1/3 times x, which is 18 plus 5. So that's going to be 14 equals, now if we use our quick multiplication, this 3 and 18 are divisible by 3, so that's a 1. This turns into a 6. So you have 1 times 6, which is 6. 6 plus 5, nope. It doesn't work. 14 is not 6 plus 5. On to number 5. You have 2d minus 4 equals 8. So now you have two numbers you have to get rid of, the 2 and the minus 4. We always get rid of the standalone first, the number that's not attached. So this minus 4 is all by itself. So to undo a minus 4, we're going to add 4 to both sides. So we have 2d is equal to 12. That 2 is a multiplier, so we're going to divide. Because 2 divided by 2, they cancel, so you're left with d equals 6. Again, you can plug it into the equation to see if it works on the day of the test, but it does, so we won't check it now. Number 6, we have 14 equals negative 8 plus k over 6. So here's where we have an issue. We have a fraction. And that fraction is we have a 6 on the bottom. So this is when we talked about in class using our fraction busters, which states that you can take any equation and multiply everything by the same number and you still have a true statement. The reason that's helpful is because if I decide to multiply this by 6 over 1, we've learned that the 6's will cancel each other out, so you're left with just a k. But if we're going to use a fraction buster, we have to multiply every term. So the negative 8 gets multiplied by 6 and the 14 gets multiplied by 6. So that gives me 84 equals negative 48 plus k. Now I don't have to worry about fractions anymore. So I have to get rid of that minus 48, so we do the opposite. I add 48 to each side, and I come up with 132. So 132 is equal to k. On to number 7. Number 7, we have 3, parentheses, w plus 9 is equal to 20. So from here, we are going to distribute over, because we got to get the pieces out of the box. So 3 times w and 3 times 9. So that's 3w plus 27 equals 20. Now we have a 3, we have a standalone 27. We always get rid of the standalones first. So we are going to subtract 27 from both sides. So now we have 3w equals negative 7. The 3 is a multiplier, so we divide with it to cancel it out. So now we're left with just our w is equal to negative 7/3. And you can change it to a mixed number if you want to, but we don't need to because it is kind of a waste of time. Alright, on to number 8. We have 8m plus 7 equals 5m plus 16. Well, now we have an issue because we have m's on both sides. If we're solving for a variable, the variable can only be on one side of the equation. So we always want to deal with that first. So I'm going to choose to get rid of the 5m's over here. I don't want the right-hand side to have them. So I'm going to take away those 5m's. And if I take away 5m's on the right, I have to take them away on the left. So now I'm left with 3m's plus 7. These are gone, so you're left with just a 16. Now we're back to the regular getting the variable by itself. We have an attached 3 and a standalone 7, so we get rid of the standalone first. So we do the opposite, which is subtract 7. So now I have 3m is equal to 9. The 3 is a multiplier, so we do the opposite, which is to divide. They cancel out, so you're left with m is equal to 3. Number 9, we have 2/3 w minus 10 equals 1/3 plus 5w. So here again, we have fractions because we have this 3 on the bottom here and over here. So what we want to do is multiply everybody by that denominator. So we multiply this by 3, we multiply the 10 by 3, the 1/3 by 3, and the 5w by 3. So let's look at what happens. This is really a 3 over 1, so when we multiply, we've learned that the top and bottoms will cancel out. So 3 and 3 cancel, so you're left with 2w. 3 times a negative 10 is a minus or a negative 30. Here the 3's cancel, so you're left with a 1. And now you've got a 15w. So now we've got w's on both sides. So we need to get rid of one of them. It doesn't matter which one. So this time I'm going to say these two w's, I don't want the left-hand side to have them. So if they have two w's and I don't want them to have them, I take them away. And then I take them away from the other side as well. So now notice that I only got rid of this term. I didn't get rid of the 30 or the minus sign, so both have to drop down. 15w take away 2w leaves you with positive 13w's. Now we play the game of opposites. We've got a standalone and we've got an attached. To get rid of our standalone number, that's a 1, so we would subtract 1. And then I do it to the other side as well. So negative 31 equals 13W. The 13 is a multiplier, so we do the opposite, which is to divide. And now we're left with negative 31 over 13 is equal to W, because those 13's canceled. And again, this is why on your test Tuesday, make sure you're showing your work like this to where I can follow it and look at your work. Because let's say you did negative 30 minus 1 is negative 29, but you did all the steps correctly of showing me what to do to get rid of the numbers. I only take off a point or two for a miscalculation. But if you don't show all the steps, or you show them in a way that isn't logical, that I can't follow, then if you do a miscalculation, I have to take off full credit. So that's why I've been working on showing our work in this vertical fashion. Alright, on to number 10. We have 2 parentheses W plus 3 plus 5 equals 2W plus 6 plus 5. So we've got W's on both sides, but we can't move anyone yet because these guys are trapped in the parentheses, or it's our pieces in the box. So we distribute to get them out of there. So 2W plus 3 plus 5. Oop, let's see. I went too fast. 2W plus 6, because we multiply the 2 and 3 together, plus 5 equals 2W plus 6 plus 5. So we've got W's on both sides, so I'm going to say this side can't have them, so I'm going to take them away, which means I take them away over here as well. So now I have 6 plus 5 equals 6 plus 5. Well, the variables are gone. Now this hasn't happened yet. So when the variables disappear, and you're left with a statement that actually makes sense, it's a true statement, we write that the answer is infinite solutions. Or you can write the word that we've been using in Math Excel, identity. Any number that you plug in for W will always work because it's the same thing on both sides. So therefore we could pick any number we wanted to. Number 11. We've got 10x minus 4 equals 2 times 5x minus 3. Again, x is on both sides. Can't move people because we got people trapped. So let's get these pieces out of the box. So now I have 10x minus 4 equals 10x minus 6. We've got x's on both sides, so we decide who we don't want to have them. I'm going to say left side, you can't have those 10x's, so I'm going to take them away from you, which means I take them away from the other side too. And I'm left with negative 4 equals negative 6. Now this is different. Again, variables are gone. We have a number statement, but this number statement is false, in which case we don't write infinite solutions, we write no solution. Alright, for number 12, you're filling out a table. So they start off with this, 4 parentheses x plus 3 equals 20, and then they write the word given. Given just means, hey, this is what we give you to start the problem. Then the next step down, they show you this, 4x plus 12 equals 20. They ask you, well, what did they do to get there? What's the proof? Well, they used the distributive property. So it's like you're looking at someone's work who didn't show it, and you're figuring out what they did in the background. Kind of like what I have to do sometimes for y'all's work. So then it comes down to here, 4x equals 8. Well, we see that the 12 is gone, so we just say, well, how do you get rid of a plus 12? Well, you subtract it. So we call this the subtraction property. Technically, it's the subtraction property of equality, but on Tuesday's test, if you just say subtraction property, that's going to be fine for now. Then it gets to x equals 2. Well, you go, well, the 4 is gone. How did they get rid of the 4? They divided. So the division property. And again, division property of equality, but if you just write division property, I'm good with that. All right, number 13. We have 2 over x plus 8 equals 3 over x minus 2. You learned last year in Math 2 that when two fractions equal each other, their cross products should be identical. And some teachers call this the butterfly. Some people just call it the cross multiplication. But that's what we're going to do. we're going to do 3 times x plus 8, which gives you 3x, not plus 8, 3x plus 24, because both the x and the 8 get multiplied by the 3. That's going to equal this multiplication problem, 2 times x minus 2. So 2 times x is 2x, 2 times negative 2 is negative 4. Now you've got a problem that we were working on a while ago. X is on both sides. I'm going to say the right can't have those x's, so I take them away. So now I'm left with 1x. You don't have to put the 1 there, but you can. To get rid of that plus 24, we do the opposite, so we subtract 24. And now I'm left with x equals negative 28. Again, you could go take that negative 28, plug it back in here, and see if it actually works. It does, but you can check that on your own on the day of the test. Number 14, we have a word problem, so you have to look at your study guide for this. But there's a key word in the word problem. They use the word rate. Rate automatically should get your mind thinking of ratios, where you're comparing two numbers to each other. And they are comparing two numbers. They're comparing pickles to hours. And they say he can eat 20 pickles in 3 hours. Then they say, well, how many pickles? So we don't know the pickle number for the second scenario, but they do tell us the hours, 7 hours. And notice how I kept my label. Since I put pickles on top of this one, pickles goes on top over here as well. So we have our two fractions that equal each other. So we're going to cross multiply again. So 3 times x is a 3x. 20 times a 7 equals a 140. To get rid of our 3, we do the opposite. It's a multiplier, so we divide. And normally that would be your answer, 140 over 3. But because this is a real-world problem, we want to give an actual number answer that's not a fraction. So we're going to do 140 divided by 3. So 4 times 3 is 12. Subtract, bring down our 0. 3 goes into 20. 6 times 3 is 18. Remainder 2. So technically this would be the fraction 46 2/3. But they say how many whole pickles can he eat. So he could only eat 46 whole ones because he didn't have enough time to get to the 47th completely and finish it. Alright, our next one has the age question. Now, anytime there's an age question, always ask yourself, who would you want to know the age of to figure out everyone else's very quickly? And it's usually the one that's mentioned twice in the problem. So in here they mention the hedgehog twice. So we're going to make H our guess number, so to speak. Well, if we read the question, it says, so H is going to be the hedgehog. It says the frog is twice the hedgehog. So if we knew the hedgehog's age, we would double it. Well, since we don't know it, we just double its variable. So that would be A2H, and that would be the frog. And then the cricket says it's 3 years older than the hedgehog. So if we know the hedgehog's age and add 3 to it, that would give us the cricket. So we've got all of their ages in terms of variables. So it says the sum of their ages. So a H plus a 2H plus another H gives you 4 H's. You still have your plus 3 is equal to 131. Now we play our game of opposites. We got a standalone number, so we get rid of it first. So now I have 4H equals 128. That 4 is a multiplier, so we divide. And I get H is equal to 32. So that means the hedgehog is 32. The frog is 2 times the hedgehog, which would be 64. And the cricket is 3 years older than the hedgehog, which would make him 35. On to 16. 16 now we're going to solve for y. And what gets confusing about this, and I understand why it is we start putting more variables in. But I still want you to think about it in terms of the game of opposites. You got to get y by itself. So you've got to get rid of the 2, which is attached, and you have to get rid of these 3 x's, which are standalones. So we do what we've always done. We get rid of standalones first. So these 3 x's, we can't have them, so we take them away. And we take them away from the other side. So now I have 2y equals 9 minus 3x. Now I have to get rid of the 2. It's a multiplier, so I divide. Now here's where it's a little bit different. Normally there's just one number over here to divide by 2. Well, now there's 2. So both of them get divided by 2. So now your answer is y equals 9 over 2 minus 3 halves x. And if you want to write it as 3x over 2, still that's okay. But this is the more appropriate way to put the fraction in front of the variable. We're solving for x. And we have x plus 2 over y minus 1 equals 3. So a lot of us were confused on what to do with this one. And this is a fraction. And if I have a fraction equaling a fraction, I know I can cross multiply, but I don't have a fraction over here. Well, let's make it into a fraction. Let's just put it over 1. Now you have a fraction. Now you can use your cross multiplication. So we do 3 times y, which is 3y. 3 times negative 1, which is negative 3. Then we do 1 times x, which is x. 1 times 2, which is 2. We're solving for x, so we just got to get rid of that plus 2. So we do the opposite. We subtract 2, and we have 3y minus 5 equals x. 18. Word problem. It says, at the game there were 573 fans. And it said that there were students and non-students. They say x is equal to students and y is equal to non-students. And they give you a whole bunch of expressions asking you which one of these expressions could represent the situation. Well, option A is easy. They say if you add the students plus the non-students, you should get 573. So A works. C also works because it says 173 and 400. Well, if you add 173 plus 400, you get 573. So C works. And the only other one that worked was E, because it says y equals negative x plus 573. So if we take a look at that, it kind of looks like this equation, except this one, the x and the y are on the same side. So all we have to do is manipulate this equation. If we want to get the x over there with the y, we would do the opposite, which is add x. Add x. So now look at what you have. X plus y equals 573. And that's exactly what A was. So you just had to manipulate this equation a little bit to make it look like 18A. 19. Lots of words in here. It says we're going to have 300 calendars printed. And we're going to have to pay, or let me write this. It cost $4 a calendar for printing. We're going to sell them for $10. And so they give you an equation, P equals 10N minus 1200. And they say in the problem that P is going to represent profit, and the N is going to represent the number of calendars. That you sell. So it says select all the true statements below. Well, the first statement is true because it says 10N represents the money from the calendars, the money you make, which is true because we're going to multiply every calendar by $10 to get our sales. And the third one is also true because it says 1200 represents your payment of the calendars, payment for getting the calendars. You might be going, well, that 1200 wasn't mentioned anywhere in the problem. Well, it says that you're going to buy 300 and that it costs $4 for each one you buy. So 300 times 4 is 1200. So that's what we call your expenses. which you need to know that in order to do number 20, because number 20 says what is your max profit. Well, your max profit would be if you sold every single calendar that you have. So if we sold every calendar, that would be 10 times, it says we bought 300, so it would be 10 times 300, which would give us 3,000, which would be great if that was your profit. But now with all things profit, you have to subtract your expenses. Well, our expenses was the $1,200 to actually buy them from our distributor before we could sell them. So 300 minus 1,200 is 1,800. And with that, that is the end of the study guide. I hope this is very helpful in preparation for Tuesday's test.